G'day guys. Had a detector that was behaving a bit strange out in the field. That it was noisy. I kept getting told that it was noisy. I tested it here in various modes, and in cancel mode it wasn't noisy at all. But it kept going out in the field, and I was told it was noisy. So I went out here, and it wasn't noisy. It worked fine. But what I did find is that when I got very close to some high voltage power lines, well, this is normal. The detectors become noisy. They start picking up, the 50, 60 hertz, whatever it may be, harmonics, the discharges across the insulators. There's always a little bit of discharge across the insulators, which creates high frequency noise. Uh, Even just the humidity of the air on high voltage lines will cause a bit of discharge, and that'll upset detectors. Anyway, I went on a bit of investigation about this. Now, I had two detectors with me. I had my own, and I'd done a bit of work on my own. I'd done a little bit of extra filtering. And what I found is that my own detector wasn't very susceptible into picking up the noise. So I went on a little bit more of a look-see into these detectors and had a look at what I'd done. And I'd actually done more filtering on the supply rails, and I also did a little bit of decoupling on the audio. Now, I'll explain with this GP4500 here that where the connector comes in. The connector comes in, goes onto this Mylar circuit board. Well, it's a flexible, I just call them Mylar, flexible Mylar strips. It is technically a circuit board, but it's an interconnect. So these are your connections on the bottom that push into the socket. So I'll get my little screwdriver here. We'll point away. I'll just do this. This is pretty easy. You can see this one here goes in on a screw on the case, metallized, and it connects to this, we call it aluminium, and the Americans call it aluminum, and so do Canadians. Anyway, depends where you're from and what it's called. Anyway, it's stuff made from bauxite, if you really want to know about it. Anyway, connects on here, and that is the earthing or ground connection here, and that runs off onto the battery negative and goes down this big fat strip here, ends up going to the circuit board. And anyway, the one down here, that's the positive from the battery. And I don't know if you can see these two dark ones are actually on the other side of the board, or other side of the strip. They, you can see here, it's these two, one here, one there, and you can see there it's got a couple of little through plates, and it through plates to the metallization on the back. You can see that, and that those two tracks then run up, and they go to here and here. So that's your audio connections. So you've got ground, positive, audio, audio. Now, where this goes into the board, there is some filtering done on the board where it goes in right near the connector here. And rather than pick up the board and, well, I'll just use another detector rather than pick that one up. Okay, this is when I actually is my own, and I'll point out I've added some extra filtering on these points here, 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 and here. Okay, and the connector is along here. These are the connections. Now there is some components here that do filter the incoming lines, but some of them, actually, some of them are not filtered, if you can see. Maybe that might be the power. They're inductors, the power there and there, and there's some capacitors and some inductors. Even on the input lines here, up the top where it goes onto the front controls, there's filtering here. So there's filtering in and out. But what I think is happening, it's not enough. I don't think it's enough and doesn't cover DC to daylight, as in a frequency range. Maybe it's targeted towards higher frequency noise, and it may be limited on low frequency power line interference. Anyway, I'll get onto that, how you can clean it up. Well, I've done it on the bottom of the board by putting extra there, but my thought is that where your connector comes in here, right, you've got all this track work along here, and the tracks, you've also got data lines for your functions along these small tracks here, and they all run down, they're all next to each other. And you think about this, and when I used to do RF design work, what I would do on every input connector where it came in, I would bypass the connections to ground with small value capacitors. Normally something like about, it depends on what it was, 0.001 or a 0.1 microfarad capacitor. And by bypassing it, it doesn't allow any signals to travel down these tracks. There could be coupling, radiation, or track to track to track, or something. I don't know. When it's all sealed up in its box and you're using it, you don't know what's going on. And then if you take the box away, you've just made the situation 100 times worse, and you can't work it out anyway. You would actually have to drill small holes in a box, in a detector box, and use a miniature coaxial cable, something like this stuff here. It's a miniature one, and connect in here, and then have it externally on an oscilloscope, everything shielded, and be out in the bush and observe if there was anything getting in if you went near power lines. But anyway, to cut it short, you don't really need to do all that. All you got to do is bypass every line coming into the detector. And what I found is probably a good way to do it. I'm looking here for, there it is right in front of my face as usual. Now, no one's got capacitors lying around, but I got this off eBay. It was really cheap. It's got a whole heap of values of some monolithic capacitors in there. It's 0.1 microfarad and all the way up to 10 microfarads, and there's only a few bucks. And yeah, this was some, I can't remember the name of the shop on eBay, but I think the fellow lives in Mortlake in Victoria, who sells these. So I'm giving him a plug, a free plug. But anyway, what we can do, we can look. We've got a good selection of values here, and for this thing, looking at low frequency, we're going to do the audio lines. We don't want too much capacitance on the audio lines because they are basically high impedance relatively. They're not very low impedance lines. We don't want to send our signal to ground and basically send the audio to ground, and you won't be able to hear it. So what we'll do on the audio lines, we'll use 0.1 microfarad. And on the supply, I think that we should use probably half a microfarad. We'll use 0.47 microfarads on the supply. Before I do that, I'm going to show you a trick that will allow your connectors to last a lot longer than what they do. When these, and I'll say this loosely, in my opinion, when these connectors, any of these connectors, are put on the connect or the mylar connection here, what I think the way they're done is that they just put this on and then they solder it or solder it. Okay, so they all get I'm going to say adhered. How's that? So we don't get a soldering confusion going on. No. Well, anyway, they're connected with that lead and tin stuff, whatever you want to call it. And these connectors, if I actually had one that wasn't installed in a board, if you actually grab the pins, you can move them left, right, up and down. They wiggle all over the place. And when these are put together, you don't know if it's actually pulled left, right, up, down, and so forth. So what actually happens when you get your connector with nice straight pins, I don't know if you can see that. Well, you own one of these detectors, you'll know all about it, but those pins are pretty straight. These don't wobble. There's no way known they should. So they're all the same when these are made. You know, they come out the same factory. They're all locked in that position perfectly. And when you get one of these and you say, okay, we're going to, I'll zoom out again. When we're going to put this in, like so. Now, it's actually a fairly hard push. You know, a lot of force. Now, what I do, I'll show you this. Now, I've got a live battery on this. You should use just a connector with nothing connected, because if you short the positive to negative, you'll probably set your battery on fire. Don't do what I do, but I've done this before, so it's no big deal. But I'm just careful, okay? So you've got to be careful. Now, you hold your mylar. Just remember too, these will be live now as well, the ends. So what I do is hold the mylar like so I can get onto it. And one by one, with the connector pushed in, see, I heated that up and it actually moved. I don't know if you can actually see that. Pretty hard, but I'll heat it up. Yeah, it moved. It actually just leant away and went upwards. So what it's doing, it's aligning itself perfectly with the pin orientation, which is basically, you know, a straight. It's meant to be straight, so it's a straight orientation. That moved as well. I'll get onto this one here. That moved as well. They all move. So you don't know how it was put together. I'd say they're just not aligned and just hit with a soldering iron. And that one stayed still. So most of them moved and one stayed still. Now, let it cool down. The other thing too, don't heat these for too long because you might get some, you know, too much heat onto the connector. It might do something to the gold flash metallization on the pins. And that came out really easy then. We'll try it again on the end. Line it up and give it a, oh, there we go, so do it around there. Got plenty of bite on it, but it just feels more positive and less resistive. So they're all going in neat. That'll actually help these connectors last a lot longer going in and out. If you've got a hard push on one side of these connectors, it'll take the gold flashing off the pins and you'll end up with a nickel base. And then under the nickel there's stainless, or it's not stainless steel, it's just steel actually. And what ends up happening is that you'll get really bad contacts and you get noise. So to keep these things going good, give them a touch up. I've got a visitor. Oops, just knocking everything over. What do you want? I need a rubber. I haven't got one. Out. Go out. Out. Where was I? Yeah, he comes in, knocks stuff off the table because there's stuff everywhere in here, of course. So yeah, just by resoldering those with a connector in there will align up the little socket parts with the pins. The other thing too, I'm going to tell you this. This is I found out this the hard way. I had some battery connector like so, and it was a pair of tweezers like I use for grabbing components and things. And the battery connector, right? You won't believe it, but it went straight in there and blew up the audio amplifier, put volts up the output lines of the audio amplifier. Be very careful with these connectors. You know, it may look like it's recessed and all sealed, but metal gets in. Screws, metal tip tools, anything will get into these. They should have a rubber cover on them, like a rubber cap or something to stop anything like that happening. You got that sitting around bouncing in your car, and something metal comes up and hits that. What's it going to do to your battery? Or if you've got an amplified system, it'll blow things up, or could short your battery out and set it on. Basically, your lithium batteries are like. Be careful. I've seen too many EVs blow up to treat lithium batteries. Like they're benign. They're not. They're touchy things. Anyway, let's get on to this, the anti-interference. So what I'll do here, I'll open this up, and hopefully I don't fly capacitors all over the place when I do so. No, that's all right. Now, what I said I was going to do, I'm going to put a couple of 0.47s on the voltage rail, and I'm going to get a couple of 0.1s and stick them on the audio rail to ground, to earth. You can connect these across the rail as well. I don't think you need to really do that. What I will do, so I do a really good job on this, I am going to get my set of 4-eyes, wherever they are. Here they are. Okay. So what I would do on the power rails, well, I don't really have to, it's funny, isn't it? Because it's negative ground, so I don't have to bypass the negative, do I? Funny about that. Okay, let's get to have a look at these monolithics, just make sure. Yep, they're fine. They're in the right spot in the drawer, but okay, I don't need to, that one there's not connected, so what I'll do, you can trim the legs on these and make them a little bit nicer, but I don't think it's an issue. Okay, want something to push that down. So I'm just using these. I haven't trimmed the legs or anything. I'm just going to show how to do it. Hopefully, what you see is my hand there, of course, but you get the gist of it. Okay, so that's done like so. Bring it up so you can have a look. And that, like I say, that is negative ground. That one there, as far as I know, doesn't go anywhere. I'm pretty sure it does, unless it does go to ground. I've never really taken any notice of that pin. No, it's sitting there all by its lonesome. So it's a spare there for whatever reason, if you need one. But yeah, see, I've done that. I've stuck that from the negative to the positive, so that's bypassed. And what you want to do now is you want to go from on the audio, from there to ground, and that audio to ground. You can go across the audio as well, but I don't see why, in all reality, you would need to do that. So what I'm going to do, I'm going to put these 0.1s. Normally when I do soldering and stuff, I'm not making videos, so yeah, it's a bit difficult, and there's everything in the way, but I'll try and do it. So okay, You got to remember I've got the connector off. We're not got any power on this whatsoever. And I probably just stuffed up by moving that pin after all the hard work I did by aligning it. But anyway, okay, stick please. Oh, there's enough resin here, so I'm not tinning up the component legs. Come on, there you go. There we go. The solder or solder, whatever you want to call it, is normally a lead-free type solder, and it needs a lot of temperature to melt it, not more so than anything made of lead and tin. And all I'm going to do now is just do the last one, which is over here. We'll just have a listen to the noise after I've done this in the room. I just want to see actually if it has any really interesting effect. Now I've got to stretch this one over here, which means I've got to cross a leg. I've got to cross this leg here. What I should do is I should go in the middle, which I will. So I'll just do that to the capacitor so it's had the leg spread open. Sounds funny saying that, doesn't it? But anyway. Get this high temperature solder to melt. Yeah, got that tacked on. And you got to be careful doing this if you're doing it the way I'm doing it. You don't want it touching there over onto the positive. That would be disastrous. And I'm getting quite sick of this high temperature solder. So I'm getting some solder. And I was going to touch it with a bit of this. There we go, low temperature stuff. Beautiful. It actually works. So he's on. I was giving it a touch up. Okay, get rid of that iron. I'll trim the legs up on these ones. They went a bit too far over. Okay, that's done. That was pretty simple, wasn't it? I mean, the legs look very long there. You can probably cut them and bring them right in. But, you know, it's not going to do anything. You know, I'm not trying to stop microwaves getting in there or something like that. So I'm not going to worry about it. Okay, get everything off this. Don't touch that. See what I mean about the plugs? It's going onto the circuit board. You know, if there was metallization there, it's a chance it could short out. But on these batteries, these are the batteries that we make. I do have current limiters there. So if you pull more than an amp out of the battery, it will shut down. And it's an added safety feature that I've built into the batteries. So they're pretty safe. 1 amp at 8 volts is 8 watts, and you know, you couldn't do much with that. Anyway, so we got this gadget hooked up. Let's get rid of that one over there, and I'll plug this in because I've soldered those pins and they moved. It's harder to push in, but it goes in, and we'll turn him on. Make sure there's no metal under the circuit board. Let's see how this sounds. That's not too bad for this time of day. I've got solar installations on all the houses around me, and it causes a heap of noise. Let's turn off the oscilloscope. This is on factory default. I'll just put it on factory default just to make sure that I haven't fiddled with anything. I have got the audio quite loud actually on this. So that's quiet as. There's a few little impulses coming through, but that is a lot better than what it was. Actually, I should have done before and after, shouldn't I? But I didn't. That's really, really good. I'll just get the small test target here. We'll see how we go. On this, I'll use 0.05 up on the coil. That's how loud the audio is. I'm only using the small target. I'll use a 0.1. We'll use a 0.1 on the coil. Oops, bang the tripod. Okay, that is beautiful. That is really good. So maybe there is an advantage in bypassing the cables here. I think, this is only my opinion, right? Anyone using a standard battery with a big, long, curly lead, the big, long, curly lead can actually act as an antenna, right? And think of a TV antenna or a dipole antenna. You could actually look at the battery lead running off as one leg of a dipole and the cable from the other side of the detector to the coil acting as the other side of a dipole. And the center point, which we call the low impedance point, is your antenna, the detector. And you got something like a dipole antenna, and you have got electrical interference access through the connector, and it is bypassed on the board, but you do have all this area here with no bypassing. Can it couple into all these other tracks here and re-radiate inside the detector? I don't know. It's feasible, it's possible, and it could be. I hear stories about people that go, "Oh, I'm out here and the detector's gone crazy and I'm getting all this strange noise." Well, the funny thing is that the coil actually acts as a low pass filter in its design. It's not really, the detector isn't set up to pick up FM radio stations and even the higher frequencies in the shortwave spectrum, stuff like that. But just AM radio stations, they do get in. We know that. But maybe this is part of the way it gets in. I don't know. But there's nothing wrong with sticking a couple of caps across there and bypassing it to ground just through the little strip here. That's a low enough impedance. When this is in the case, it should be even quieter. It should be a lot quieter. Just thinking of anywhere else, not really. You got your coil connector in here. You got no choice. You can't go and bypass these with capacitors. The detector won't work. It'll make it all go deaf as a post. So you got your ferrite here, but the ferrite's more to stop things coming out from switching than anything coming in my opinion. It does both, but you also can lose input signal going through this ferrite as well. You shouldn't, but I know it does. I mean, if you start looking at the frequency response of these ferrites, they shouldn't have any real effect down low in frequency, but they do. It's just because it's a big, quasi-metallic structure, and you're sticking your signal through it. So there is issues there. It's mainly just to knock off the high frequency. Any harmonics off square waves in a transmitter that tries to squash them, knocks off the edges a little bit. So it may be an EMC compliance thing, like I've always said. But yeah, there you go. This is cranked. It's running factory gain. I've got it on a cancel call, well, not a cancel call. I've got it in cancel mode because if I put it in normal, it will go completely bonkers. But it has quietened it. So that is, I would say that is a good little modification or upgrade, improvement to the detector. Um, so yeah, apart from that, I'm going to turn this off. I'm going to go and resolder the connectors here with the plug-in, just to make sure that they line up properly and they're not bent over, or going to get scuffed out on the gold plating over a long period of time. You know, um, you could even, you can't really, but I'd like to. Um, Normally on the coil ones, they're pretty well set. They're sort of got hard, whatever it is, plastic resin or whatever around them. They can't move, so can't really do much about that. And yeah, the back one you can. That goes for all the detectors. The back power connector. You can do something about that. Yeah. Okay. That's enough of the waffle. So that's an improvement. Very good improvement. We've got some more stuff coming out for these detectors. I've got something that are going to absolutely um, spin everyone out. I think I'm in the middle of designing it actually, so it's a mixture of digital and analog, and what do we call that? Digilog? No, I don't know. It's more to do with the audio, and it's going to be very, very, very interesting. So I have to get onto that. Anyway, enough waffle. I've got things to do. Catch us later. I'll turn that off and turn that off. See you.